Hello my girls, thank you for being here.
Thank you, sir.
Okay. Now for this class, I am not proposing any title. I am throwing some questions and I think your answers will lead us to the path directed towards the title. Okay.
Okay, sir.
Okay. Now suppose X stands for the total number of students in your class. X is the number of students in your class and we are in need to create a fund for the decoration of your class. Okay. Then if each of you gives a contribution rupees 7, contribution of rupees 7, then what will be the total contribution?
Then the
Answer
total
me.
contribution will be rupees 7x.
Will be rupees 7x. Okay, good. Now just get rid of the unit here. We are considering the expression only. Then we are considering 7x. Okay.
Okay, sir.
In this term we have two factors, namely 7 is the first factor and x is the second, and for the first factor 7 it is fixed. Okay. It does not depend on the class, does not depend on time, etc., and x stands for the number of students of your class. If we move to another class, then x will vary naturally. Therefore, what is the name of x to be supposed by you?
X is not fixed.
Not fixed. In mathematics, we will call x as a variable. Therefore, in this term we have two factors. One is 7, which is constant, and the second is x, which is a variable, and the number of terms here is 1. Okay. Suppose you are contributing x plus 1 rupees each, and you are x in number, remember that, then what will be the total contribution?
Then it will be x into x plus 1.
X into x plus 1. After simplifying and neglecting the unit, we will get
X square plus x.
x square plus x. Here we have two terms, namely, finish my sentence. Here we have two terms.
Yes, one is x square and the other one is x.
Second is x. Okay. And in this very expression, we have two terms, and the name given to this expression is binomial. Binomial. Okay. Then can you guess the name of the first one, that is 7x?
Monomial.
Mono stands for 1.
1.
Monomial. Okay. Good guess. Now I did not give any contribution to your fund. Now I am ready to contribute the same rupees 7. Okay. Then proceed. What will be the total contribution?
Then it will be x into x plus 1 plus 7.
Plus 7. Okay. Then after simplifying, we are getting
X square plus x plus 7.
x plus 7. And the number of terms here, total number of terms
Here
is
the
3.
total number of terms
Then we
is
can give the name
trinomial.
try for 3, trinomial, trinomial. Now we are in the position to consider the general structure, general form of a complete my sentence, where we are considering arbitrary number of terms.
So it can be polynomial.
How have you got it?
So like in geometry we have pentagon for 5 sides, hexagon for 6. So
Okay.
similarly for arbitrary number of terms we say it polygon.
Polygon.
So similarly in this expression also, if there are arbitrary number of terms, then possibly we can call it polynomial.
Okay, you have reduced my job. It is polygon. Polygon. So we are considering the general structure of the polygon. Okay. Just look at the screen. General expression for a polygon, polynomial, sorry, polynomial. You have used polygon, so I am uttering the same word, polygon.
Yes, sir.
We are considering the general expression for polynomial, which is a0 x to the power n. I have seen in 7x we have a factor 7 like a constant, and another factor is a variable. Here for the first term I have a0 for the constant factor and x to the power n for the variable. For the next term the power will be reduced by 1. So, we are getting x to the power n minus 1 and the coefficient is denoted by a1 etc. up to last term is a constant term a n. Therefore, the power index of the power of x is being reduced here term by term. Here a0, a1, a2 etc. up to a n are all real numbers, and the set of real numbers is denoted by capital R. Look at the picture, and the indices of the powers of x are whole numbers. Do you know the set of whole numbers?
Yes, the set of whole numbers are running from 0 to infinity.
Set of whole numbers is 0, 1, 2 etc.
Up to
going towards infinity, but infinity is not being included in the set of whole number.
Okay.
Endless 0, 1, 2, this sequence is endless, just all. Now, please observe a thing. For the first term a0, here 0 is called the suffix of a, for the second term 1 is called the suffix of a etc. Now, for the first term the sum of the suffix of a which is 0 and the index of the power which is n, sum is 0 plus n, 0 plus n, that is n, and for the second term the suffix of a is 1 and the index of the power is n minus 1 and the sum is n. Please check it for the other terms. For the general term, that is I mean a r x to the power n minus r, what is the suffix for a?
The suffix for a is r, and
A is r, and
the index of power is n minus r.
n minus r. What will be the sum?
The sum will be again n. So, I think this is satisfying.
Okay. This is the magic of this very expression. This is the general expression for a polynomial, but we have two restrictions. The coefficients must be taken from the set of real numbers and the indices of the powers of x must be taken from the set of whole numbers. That means, we can take 0 or any one of the positive integers. Okay. Now, we proceed to this worksheet where some expressions are being given and you have to check whether the expression is a polynomial or not. Okay. I have written yes and no. According to your answer, I will strike off any one option. For the first expression, we have 5 x cube minus 7 x square plus 11.
Yes, sir. For the first expression, it is a polynomial
Why? Give a short explanation.
because it has 3 terms, 5x cube, 7x square, and minus 7x square and 11, and all the indices of the powers are whole number,
Namely 3, 2 and
0.
0. Okay. So, this is a polynomial. I am striking out no. And for the second one,
The second one is not a polynomial, sir.
why?
Because for the first case, the indices of the power belongs to the whole number set, but in case of the second term, x to the power half we
I
are
have
getting
written root x. Root x is nothing but x to the power
x
half.
to the power
Then
half, and half does not belong to the set of whole numbers. So, that is the reason this will not be a polynomial.
Okay. No, this is not a polynomial.
Yes.
Therefore, we should strike out yes option. No will stand. Okay. This is not a polynomial. Next, for the third one,
For the third one, no, it is not a polynomial,
why?
sir, because if we simplify it, then it becomes u plus 1 by u.
U square by u will give u and 1 by u will be 1 by u. Then
Yes,
what is for 1 by u if we write in this manner, u to the power
minus half.
minus 1, I think.
Sorry, minus 1.
If it was be written as 1 by root u, then it
Yes,
would be
yes,
u to the power
would be
minus
minus
half.
But since it is minus 1, so it is not, it does
Minus
not
1 is
belong
not
to
belonging to the set of whole numbers,
the, yes, that is why it is not a polynomial.
not a polynomial. Okay. And for the fourth,
For the fourth one, it is a polynomial Because the indices of the powers are whole number, that is 2, 1 and 0.
Okay. But the coefficient for the first term is an irrational number, root 7.
Yes.
But do not consider that, we will have to check only the indices of the powers. Okay.
Okay.
It is a polynomial.
Okay.
Now, consider the second one again, that was 3 x square minus root x minus 7, and you answered correctly that it is not a polynomial. Now, my question is that, can you transform this very expression to a polynomial one?
Sir, I am getting confused. What to do exactly?
Okay, I am giving a hint. Just put root x is equal to y. In other words, x is equal to y square. Then what will be the reduced form of this one?
Then
Root
this
x equal to y, that is x equal to y square. Then for the first term,
it
if
will
we
be
put y square for x, then what would be?
3y 3y to the power 4
3y to the power 4
minus y
minus y.
minus 7.
Then check whether it is a polynomial or not.
Yes, this is a polynomial.
So, you easily transform the second polynomial, which was not a polynomial at all, expression to a polynomial one. Okay.
Okay,
Therefore,
sir.
we can do that, but we can't do it always. For the third one, if we put 1 by u as x, then the first term u will be transformed to 1 by x.
Yes, sir.
For the third expression, we have u plus 1 by u. In order to get 1 by u to be x, if we put 1 by u as x, then the first term will be 1 by x.
1 by x.
Then we cannot reduce it to a polynomial one. Therefore, we can do it for some expressions, but we can't do it for other expressions also. Therefore, final reduction is 3 y to the power 4 minus y minus 7, which is a polynomial, and this very transformation is known as variable transformation. So, in this class we have learned just a gist about variable and constant, and about the general form of a polynomial, about the restriction on the values of the powers of the variable concerned. Here the constant variable is x, sometimes I have used u, whether a given expression would be a polynomial, and reduction of a non-polynomial to a polynomial one by variable separation. This can't be done always, remember that. Guess the name polygon, which is used in geometry, and you have guessed rightly. In geometry, we use the name polygon for arbitrary number of sides, and here for arbitrary number of terms in the expression like this, we use the name polynomial, just like polygon in geometry. You have reduced my job. Now, we are in position to consider the general expression for a polynomial, which is a0 x to the power n plus a1 x to the power n minus 1, etc. up to an. Okay.
Thank you, sir.